We already reversed the list with a loop. Now let's do it with recursion, which is a beautiful way to see the same idea. The trick is to trust that the rest of the list after the first node gets reversed for us. Then we only have to fix the one link between the first node and the second. Here is the recursive idea. If the list is empty or has just one node, it is already reversed, so we return it as is. Otherwise, we ask recursion to reverse everything after the head, and it hands us back the new head of that reversed part. Now the second node's next should point back at the first node. Since head.next is that second node, we write head.next.next equals head to flip that link. Then we set head.next to nothing, so the old head becomes the new tail. Finally, we return the new head. We define a node. In reverse, the base case is an empty list or a single node, which we return unchanged. Otherwise, we recursively reverse the rest and get its new head. Then we make the next node point back at the current head, cut the current head's forward link to nothing, and return the new head that bubbled up. Let's reverse a small list with recursion in a live editor. A node holds a value and a link to the next node. The base case, an empty or single node list, is already reversed. Reverse the rest, flip the one link back to head, cut head's link, and return the new head. Now let's test it and hit run. There it is. The recursion peeled down to the last node, then flipped each link on the way back, giving 4, 3, 2, 1. Here is the shape. If the list is empty or a single node, return it. Otherwise, reverse the rest, then point the next node back at head, cut head's forward link, and return the new head that came from the deepest call. There is one recursive call per node, so the time is order n. But recursion stacks up n frames before it unwinds, so the space is order n as well. That call stack is the price we pay compared to the iterative version, which used only order one space. 3 things. First, the line head.next.next equals head is where the flip happens, so read it slowly. Second, you must set head.next to nothing, or the first 2 nodes will point at each other forever. And third, for a very long list, recursion can overflow the stack, which is why the iterative version is often safer.